Hello friends, welcome to Wisdom Training's Hadoop Developer course. In this video, we'll be talking about big data management. But before we touch base upon big data management, let us brush up what big data is, right? So I'll just take you through brief introduction of big data again. Okay, so I'm gonna write here big data. Alright, and so this is your big data. So as per the big data's definition, it is defined as 3 V's. So the very first V stand out for volume, then you have velocity, and then comes your variety, right? So the volume, the data is getting generated of the level of petabytes, terabytes, etc. Velocity, it is getting generated at such a huge space, that is streaming data. And if you talk about the variety, it is structured, semi-structured as well as unstructured data. So this accounts to be variety. Okay, so this is the definition of your big data, that is any data which conforms to this 3V definition can be considered as big data. So if you talk about a few of the sources of the big data here, okay, so you have the data from sensors, you have your data from social networking, you have your data from big black boxes, etc. Right, so I'm just drawing the arrows first. Okay, so you have your data from sensors. So if you talk about sensors, you have your sensors at your home, you have your sensors at your workplaces. If you go to shopping malls, you go to food courts, right? So everywhere you must find one or another kind of sensor, so which is generating some kind of data, which is considered to be a big data because it would have a volume, right? A huge amount of data is getting generated every second, plus velocity, it is getting generated at streaming data because every second data is getting generated, plus it has a variety, it is unstructured data or can be semi-structured data because it is recording your motions, it is recording your images, it is recording your expressions, etc. right? So this kind of data can be considered as big data. Plus you have your data from the social network. Alright, so the platforms such as Facebook, Twitter, Instagram, etc. on all these social networking websites that you have, the data that is getting generated out of them is big data because it has huge volume getting generated at a streaming pace, plus it has a variety because you post your images, you post your comments, your videos, etc. So all these can be considered to be unstructured data, and it has a variety and can be considered as semi-structured data, wherein you have your tweets in your Twitter, you have your images in Instagram, you have your images, comments, hashtags, etc. in Facebook. So all these account to be big data. Then comes the black box data. I'm taking few of the examples here. Okay, so the black box data, the black box is present in your aeroplanes, in your helicopters, in your aviation stuff, right? So which records your altitude, your latitude and longitude, at which altitude you're flying, and what location you're flying. So each and every minute's record, each and every second's record is getting fed into this black box. So it's generating huge volume of data at very high speed, and it is also having a variety. So this kind of data that is getting generated out of black box can also be considered to be big data. Alright, then you have your satellite images, were discussed in the previous video as well. Okay, satellite imaging, I must say, so I'm written here satellite images. So each satellite takes billions of photographs each day of heavenly bodies of your earth, right, and all the heavenly bodies across the universe, so wherever it could reach, right? And so the data that is getting generated can also be termed as big data here. Machine generated data you have, then you have your CNCs, you have your heavy machinery out there in your bigger industries, which are linked with some kind of sensors or which are having their own mechanism to generate the data. Okay, so all this kind of data can also be considered as big data. You have your stock exchanges here. Alright, so if you talk about New York Stock Exchange, if you talk about, that is NASDAQ, you talk about BSE, NSE, right? So all these stock exchanges are generating huge amount of data at very high speed. So this kind of data that is getting generated out of these exchanges can also be termed as big data. Alright, then you have search engine data. Alright, so we already discussed in the previous video as well that Google performs 1 billion searches in a single day, alright, in a single minute, sorry. So the amount of data that is getting generated is very huge and at a very fast pace, and it also has a variety. So the data out of search engines can also be termed as big data. Now, so we have discussed about the big data. Now there are certain challenges how to how to store this data, how to process this data, and how to manage this data. Alright, so these are the certain challenges that we are facing for handling this big data. So if we talk about the traditional methods that we were using to manage data, right? So you have hold on, yeah. Okay, so this is you here as a user, and this is your centralized system. You have your relational database management system, that is RDBMS. Okay, that could be Oracle Developer, SQL Server, etc., MySQL, DB2, all these can be considered as RDBMS. So what you do is you interact with centralized system, which further interacts or communicates with RDBMS and fetches the result from RDBMS and give it to the user. Okay, so this kind of traditional system was beneficial when the volume of the data was not so high, but nowadays the data has grown to such a large amount that it is conforming to the definition of big data. So this kind of system is very ineffective out there. It cannot handle unstructured data, right? It cannot handle huge volume of data, plus the data that is getting generated at such a high speed, right? So you need some other solutions. Okay, so you need some other solutions to manage that kind of data, or that to manage big data. So one such solution is distributed file system, right? Let's talk about Google's algorithm on which the Google search is based upon, right? So what Google has done is it has developed an algorithm which is called as MapReduce, wherein a task is, so let's say you have a certain task here. So this is your task, okay, and your task is divided into multiple tasks, that is this one. So I've split the task into multiple tasks here, so which is a smaller portion of the huge task, right? So what it has done is it has kept a centralized system here, and the user is at this end. So this is your centralized system, and a user is present here. So you have your commodity hardware 1, I can say, CH2 and CH3 and CH4. So one task is divided into 4 multiple computers, and the processing and storage is done on these computers, right? That is map and reduce, and the processed result is passed on to, so the processed result is passed on to centralized system, alright, and then given to the user. So what it has done is it has distributed the data and deployed multiple computers or machines to solve the problem, to solve the task. So that will be faster, okay, as there's nothing shared here. So there is no scope of data failure here, or partial failure cannot exist here. So the task, it was divided into 4 parts and was given to each computer. Each computer processed the data, and the data is available with them, alright, and then the processed result, or the processed result is sent to centralized system, where it is clubbed and given to the user. Alright, so this is an algorithm which was designed by Google, which is called as MapReduce. Alright, let me also tell you another example for DFS here, distributed file system. Okay, So before we move, just need to show you the definition of big data. So big data management is the organization, administration and governance of large volumes of both structured and unstructured data. The goal of big data management is to ensure high level of data quality and accessibility for business intelligence and big data analytics applications, right? Now we're talking about why DFS. Okay, so you have here the calculate the time taken to read 2 TB of data. Okay, so here I have taken the 2 TB of data, and I have one machine wherein I have 4 input output channels, and each channel is can share the data at the rate of 100 MB per second. Alright, so if I do some calculation here, alright, so I have 2 TB of data, 2 into 10 raised to power 6, right? So this is 10 raised to power 6. So this is of these many, 2 TB is equal to these many MBs. Alright, so it has to be divided by so you have your 4 input output channels here, four into each channel is of 100 MB per second. Okay, so if we talk about the minutes that we got here is equal to 166 minutes as required, okay, to read 2 TB of data from one machine which is having 4 input output channels and each channel having 100 Mbps. So scenario 2, if you have 10 machines and you have distributed the data and you want to do the same operation, you want to read the same 2 TB of data, or you want to process 2 TB of data, and you have now 10 machines instead of one machine. Now you have 10 machines. So what will be the time taken? It will be directly divided by 10, that is 16.6 minutes. So this is the power of distributed file system or distributed processing, right? So this same thing is implemented in MapReduce and in Hadoop, alright, wherein the data is distributed and the process or the application goes to the data and process the data there, and the final result is taken back and clubbed and given to the user. Alright, so this is the solution, or the big data management can be done in this way. This is the best method wherein you can handle huge amount of data, right? So this is DFS. Alright, so moving further, you are coming to Hadoop now. So what is Hadoop? Hadoop is a framework that allows for distributed file storage and distributed processing of large data sets across clusters of commodity computers. Commodity computers are normal computers wherein they have one CPU and certain hard disk, certain number of hard disks. So it's a very cheaper way of handling the data. So Hadoop is if you're implementing Hadoop in your Hadoop architecture in your enterprise, so that will be very cost effective. It's a very low cost investments are there in developing or setting up a Hadoop cluster. Alright, it's open source data management. Storage space can be scaled out. That is, if your data requirements are getting increases, you just need to add few more or certain number of more commodity computers, so where the investment will be not so high. So as the data increases, your storage space can also be scaled out just by adding number of computers. So processing is also distributed. What do you mean by processing is also distributed? Let me just draw it again here. Hold on. So let's say you have certain number of machines here which is controlled by a machine. I'll just tell you, I'll go through the exact nomenclature of what the centralized system or the other nodes are called in the next videos, but just for now consider that it's a machine which is controlled by centralized system. Alright, so this is your machine 1 here, this is your second machine, third machine and fourth machine. Alright, now you have a certain piece of data. This is the certain data. You will split this data into a number of parts, and let's say I'm just dividing into 4 parts here. Okay, so this 4 parts, so each machine is getting this part. Okay, so that is, first part is going to first machine, second part is going to second machine, third part is going to third machine, and respectively fourth part is going to fourth machine. Right, now the centralized system, what it does is So it will interact with these machines. Now this data is present here, right? We have kept data, I'll say part 1 data, right? So data's first part 2 here, and part 3 is here, and then you have part 4 here. Now what it does is, centralized system sends the application to the data. Now the application itself is going to the data. Alright, so application is going to data, processing it there, and getting back the result. So I'm just marking the result with some other color. Okay, so result is sent back from all the nodes after processing. So here there is a lot of savage of your network bandwidth, because data is not traveling over the nodes. I mean, it's not traveling in between the nodes. Data is present in one node. The application is coming, which is a kind of program or a job. It is coming to that machine. It is implementing or processing the data over there, and then the data, the result is sent back. So result is sent back after the job is processed. All right. So in this way your network bandwidth is saved, because your data has not to travel over the in between the nodes, right? So the centralized system just takes care of sending the application to the data. So application or the job is sent to data and processed there, and result is sent back. So in this way you're saving a huge network bandwidth, plus if you're there is a, less latency, because data has not to travel. There is a less loss of there's less chances of failures, because if huge amount of data is traveling, there may be chances of crashes of the network, right? So this way you're distributing the data and then distributing the application as well. So this is a kind of Hadoop framework. So this is a Hadoop framework here. So this whole things can be clubbed as Hadoop framework. Right, so wherein you have your distributed storage and distributed processing. So distributed storage means you are sending the data, part of data to each machine, and then you're sending the application to that machine and processing it there. Alright, now coming back to the slides. So processing is also distributed, and storage space can be scaled out. We already discussed about that. Now moving on, if you talk about the characteristics of Hadoop, it is optimized to handle massive quantities. We already discussed. Share nothing architecture, as I already told you that it's not a centralized position. Data is not stored there. Data is just distributed across several nodes, and the application goes to that node, to each node, and processes it there and give it back. So there's nothing shared though. So the data doesn't has any dependency. So part 1 data doesn't have any dependency on the part 2 data. Alright, so it also replicates the data across multiple computers to avoid the failures. That will be talking in detail in the Hadoop architecture. So there are methods implemented so that there are no failures. Okay, so each data, when you are sending it to one node, it is also replicated through some other nodes based on the replication factor, which decides that your data, or which makes sure that your data is not lost. So if one node goes down, there is another node which can do the same process or same job for you. Alright, it has high throughput. If we talk about, it is not good for the work which cannot be parallelized. So here, if you see, the data or the processing is done in the parallel. So those jobs or those data which has some dependency on each other, so this Hadoop is not good for those kind of data. Not good when there are dependency within data, as already talked about. It is also not good for processing small files. So big data is only good for processing big files. Alright, now if we talk about RDBMS versus Hadoop, so if you see the system as RDBMS, and it is node based flat structure, the data that RDBMS handles with is structured data, whereas Hadoop handles structured as well as unstructured data. Data size is gigabytes, and here the data size is petabytes. processing. It's used for RDBMS is used for online transaction processing, whereas Hadoop is mainly used for analytical and big data processing, wherein you have a huge amount of data. You need to get some insight out of that data. You need to generate some business intelligence. You need to generate some functional requirements, or you need to improve your business business value. So for that kind of data you need to have your Hadoop. Alright, now if we talk about processors, it needs expensive hardware and high-end processors, whereas in Hadoop it requires only one node cluster, which is very inexpensive. Alright, and if we talk about the updates, RDBMS is read and write many times, whereas Hadoop is write once and read many times. So this is the differences between the RDBMS and Hadoop. So RDBMS is good when you have a frequent queries you have to generate, right? So mainly it is in the form of structured data, when you have your tables, when you have your rows and columns, and you want to find some, you write some query. So you have your frequent updates, you have to write frequently, wherein you have to get the data frequently. Whereas Hadoop, it is mainly used for generating the business intelligence. So it is write once and read many times to get insight into the data and develop some business value out of it. Alright, so there was another term which is similar to distributed processing, alright, which is grid computing. So if you talk about grid computing versus Hadoop, so it's similar, but here the data is on the shared file system. So data is kept at this location and multiple computers work on this. So here there has to, the grid computing programmer has to handle the network flows as well, network topologies as well. You need to take care there are no network crashes. But Hadoop, in case of MapReduce, there is no such failure, because partial failures are difficult to handle in grid computing, whereas in MapReduce there are no chances of partial failure, as there is nothing shared architecture, because data is spread across multiple nodes. So you need not worry about network topologies, right? So grid computing and Hadoop, right? So why Hadoop? It is inherent data protection. It is low cost because it is almost if you set up a Hadoop cluster, it is very inexpensive as compared to other systems available for handling big data and all. Alright, it's very flexible. It is getting cloudy. It's the support is going on cloud. More real, it can do real-time analysis as well. Scalability, if your data increases, you just need to increase the community computers. Alright, so this was all about big data management, right? So big data management is very important for getting out the business value out of the data that is available with you. Alright, thanks.